Hello everyone, and welcome to our first video in our Systems of Linear Inequalities unit. The focus today will be a skill review, and the skill we're going to focus on is graphing lines. Before we get into graphing, I feel we should review a couple topics. The first is continuous data and discrete data. So let's look at continuous data. Continuous data is data that contains or allows fractions and decimals. So we are allowed to have fractions or decimals in the questions. When graphing continuous data, we use a solid line to represent the relation. So, example, here's my x and y axes. I'm allowed to have a solid line. So when we're dealing with continuous, use solid lines. So you are used to continuous data. When you're drawing lines, usually it's continuous data. Look for data from the real number system. So if it's continuous data, it's going to be from the real number system. So we're going to look for that R. Discrete data is data that does not contain or allow fractions or decimals. When graphing discrete data, we dot the line that represents the relation. Be sure you dot only whole number points. Okay, so what does that mean? There's my x and y axes. So what that means is you might have a line. So that would be where the line should go, and you'd be used to drawing a solid line. But what we'd want to do is we'd have to actually just dot the whole number points. So right here, 1, 1 looks like 1, 2, 2, that one there, this one here. I guess I missed this guy here. The whole number, and I guess that actually dot didn't go where I was supposed to. It was supposed to go in the origin. All the whole numbers. So there is the distance between the dots does not exist. So the fractions and the decimals, that was what would be between the dots. In a discrete data question, those don't exist, so we just are stuck with these dots. Now, to identify when you should use discrete data, look for data from the natural number system, the whole number system, or the integer system. Remember that the natural numbers are, they're 1, 2, 3, moving on forever. The whole numbers are just simply 0, 1, 2, 3, so we just add the 0 and then it goes on forever. And then integers is when we get into having negative whole numbers as well. All right, so no fractions, no decimals in discrete. Let's check out an example of how to graph a line. So the first thing I think that is different in what this textbook uses is it uses a very formal notation. You can see here, it consists of 3 parts. All right, let's start at the beginning. That is simply an introduction. The bracket x comma y bracket, it's just letting you know that we're talking about points. So it's an introduction saying, okay, so here we're dealing with some points. The green, so I guess I can just write this. This is really almost like an intro. The green, this is always going to be your line or a rule that would be followed. So the points will follow this line or rule. And then the back part is simply the number system. Now, why that matters is that's going to tell us, is it discrete, is it continuous? And then if it's continuous, solid line. If it's discrete, we have a dotted line. So we can see that that's the real number system. So it's going to be a solid line. All right, so that's the notation. Now to graph. There's a couple ways we can graph this. Well, more than a couple. Technically, we can make a table of values. We can then use the slope-intercept method. So we could rearrange my line, my 2x plus 3y equals 6, into y equals mx plus b. And then there's the intercept method. So 3 methods there to choose from. Table of values is great, but it's pretty slow, so let's cut that out. The remaining 2, the slope-intercept method and then just simply the intercept method, both of those are great. I'm going to go forward with the slope-intercept method, though. I find that one is a little bit quicker, and I deal with kind of nicer numbers overall. So how do I do that? Well, I take my line, 2x plus 3y equals 6, and I'm going to rearrange it into y equals mx plus b. So you'll remember this from your grade 10 class. Okay, so I got to isolate that y. So the first thing I'm going to do is move that 2x over. The way you move something to the opposite side of an equation is by performing the opposite operation. So 3y equals negative 2x plus 6. And I want y by itself, so I have to divide by 3. and I'll clean this up, y equals negative 2 over 3x plus 2. So now it's in slope-intercept form. What I need to do then is understand or highlight the slope. So my slope is right there, m equals negative 2 over 3. And then my y-intercept, which is represented by b, is positive 2. So to actually graph it now, we always plot the y-intercept first. So here's my 2. And then I use my slope as directions to the next point. So it's telling me, well, that looks like negative 2 over 3. So I always attribute the negative to the top number. It kind of works with your left to right understanding of how we work through lines and read and everything. So I'm going to go down to 1, 2, and then over 3, 1, 2, 3. And that would be my second point. You only need 2 points to draw a line. So, and we've already talked about I can draw a solid line because it's a real number system. And you've already heard me likely complain about having to use a ruler on my tablet here when I draw, so they're not always the straightest. Sorry about that. And then good thing to do is also just mark my points down. So that's 0 and 2. And this one ends up being 3 and 0. Now the funny thing about this question is that excuse me, the 2 points that I found happen to be the x and y intercepts. So if I would have used the other method, which is the x and y intercept method, I would have actually had the exact same 2 points plotted. That doesn't always happen. It's kind of neat that it happened here. But if you want to pursue the x and y intercept method, make sure you talk to your teacher or come find me. I will show you it. I just don't want this video to be too long, so I'm not going to do everything in 2 methods. So that is how you graph a line. Let's look at another example. All right, so let's review this notation again. Here is the introduction. We really don't have to really pay attention to that. That's not going to tell us too much. It's not going to help us with graphing really. That's more of a form thing. Right here is our line, so we want to pay attention to that. We need that. And at the back there is the number systems, and that's telling me what type of data I have, discrete or continuous. And because it is integers, I know it's discrete, meaning I have to draw a dotted line, not a solid line. Okay, so I'll have to remember that at the end. I have a habit of always drawing solid lines, so I hope I don't mess it up and draw a solid line by accident. Okay, so to begin, I got to graph this line. So I'm going to write it out. This is in standard form right now. I want to put it in slope-intercept form so it's easy to graph. So I have to get the y by itself. So let's start that process. Move the 4x over. It was a positive 4x, so that's why I'm subtracting 4x. And what I do to one side, I have to do to the other side. So I'm writing the x first, and the reason I'm writing the x first is because, again, I'm trying to get it into this form. And in this form, you can see that the x comes before that b. Back to my blue line. I want y by itself, so I have to divide by -5. So y equals a positive 4 over 5x minus 4. And then now I've been successful in converting this. So my m value is the slope, so that's the 4 over 5. And the b value is your y-intercept, so that's the -4. Okay, so I've got everything I need to graph. Remember, we always plot the y-intercept first, the b value, so -4. And then my second point, the way I achieve that is I use my slope as directions to it. So it's telling me to go up 4 and then over 5. 1, 2, 3, 4, 5. Now, this is where I have to draw my line. So I'm just going to draw a little light dotted line, or well, you'll see a little line here. And this is not going to be my line. This is just going to show me where I'm going to draw my dots if I can. So I'm only going to put dots on my whole number spots. You can see this is 1. And now, why is that? Because say this point is 1 and -4. Those are both integers, so I'm allowed to draw it. But everywhere else on this line, it looks like it doesn't go through the corners. So I'm actually going to only have those lines there. Now, it could be because maybe I drew my line a little bit off. I'm just going to double check it. It's off a little bit, but it's not too bad. This one just doesn't happen to have a lot of whole number points on it. And that's okay. So if you have discrete data, you dot as many lines, or you make as many whole points as you can. But in this one, there's only 3, and what can I do? These other points, I'll highlight them in red. Like here, that if I estimated that, it would be 2, which is an integer, but then it'd be -2 point, I don't know, I'll say 2. That's not an integer, so I wouldn't highlight that point because that point doesn't really exist with these number systems because there's no such thing as negative 2.2. And anywhere else, so like here again, you might say, okay, well that's a 3, but then that's a negative 1.5 for my y value. That doesn't exist in this number system. So it's kind of strange to do it that way, but that's the way we do it. And often people will have that kind of subtle line underneath, like I drew in green, just to kind of show you where the line would be, and then we are only going to dot those whole number points. Okay, so that's our second example down. Let's keep moving. Again, we only need to really pay attention to the line and the number system. Okay, the number system, it's real numbers, so I know it's continuous. So because it's continuous, I can draw a solid line. This equation, though, is a little bit different, right? So I have x plus 3 equals 0. So let's attempt to put this into my y equals mx plus b. And the first thing that should pop up is there's no b. Or sorry, there's no y. So I can't do that. So whenever you're presented an equation with only one variable, isolate that variable. Meaning, this isn't going to work in this case. I have to just isolate my x. That'd be a great thing for you to write down if you're taking those video notes, or if you copied off that video handout that I've put up on Moodle for you guys. So we're going to isolate whatever variable we have. So I have x equals negative 3. Now I graph that. So I can't use the method I was using before because it's not in slope-intercept form, so there's not a slope. The best way I can show you this is actually to go to my table of values. So if I made a table of values, x and y, the only thing that this equation is telling me is that x is negative 3, and it's always negative 3. So it doesn't matter how many points I put down, my x is always going to be negative 3. So my y values, I can make them, like negative 2, negative 1, 0, 1. Whatever they are, they have no effect on the x. And how do I know that? Because again, if I look at my equation, there's no y in there, meaning y has no effect. So just x is negative 3. That's what I graph. So really, x equaling negative 3, that would be, I just draw lines, or I could draw my line through that x equaling negative 3 position on my graph. Because if I wanted to highlight the points from my table of values, and I'll do that maybe in green, negative 3 and negative 2 would be right here. Negative 3 and negative 1 would be right here. Negative 3 and 0 would be right here. Negative 3 and 1 would be right here. So all the points would line up on that vertical line. So anytime it's x equals, that is always a vertical line. All right. So now we've dealt with the previous two were diagonal lines. Now this was a vertical line. So if you see one in your assignment, you should be good. D, again, we want to pay attention to that. That's our line. We want to pay attention to this. This tells us what type of line I can draw. It's whole number, meaning it is discrete. Okay, so y minus 2 equals 0. Once again, you only have one type of variable. So my original method's kind of out the window. Whenever you have one type of variable, you just try to isolate it. So I'll just add 2, y equals 2. And I'll take the same approach I took last time. We'll make a quick table of values. And in this one, the equation simply tells me that y is 2. That's all it says, y is 2. So no matter what my x value is, y is going to be 2. The x is not in the equation, meaning it has no bearing on the y value. So I could go, negative 2, 0, positive 2. Whatever x value I threw in, the y would be 2. So to graph this, y equals some constant. That is always a horizontal line. So x equals just a number is vertical. Y equals just a number is horizontal. So I could go to positive 2. I mean, I could graph my table of values again. I'd have negative 2, positive 2 there, 0 and 2 there, positive 2 there. That is what, and I guess it starts to, that starts to make my horizontal line for me. I can see. I could also, if I really wanted to, draw that kind of light green line here just to kind of show you where my line's going to go. And then in this one, it's a lot easier to highlight all my whole number points. Because again, I can't actually connect these dots. because the values in between don't exist in the whole number system. Oh, sorry, I missed one here, in the whole number system. So I just draw my dotted line like that. So typically you have more than just 3 dots like that. Second example I did, and here's one where it's nice and easy to draw those dots. Okay, so that's my review on how to graph a line. Make sure that notation doesn't scare you. Really, we can just pick out those 2 important things like I was. If your equation has both x and y in it, we'll just convert our equation to y equals mx plus b. Plot your b first, use your slope to get to the next point. And if there's only one variable in your equation, then you know you have a special line, either a horizontal or a vertical. And you just isolate whatever, whatever variable you have. Okay, I hope that made sense. If it doesn't, go talk to your teacher or come talk to me. Have a great night, everybody.